Greetings, math lovers, and welcome to another video of the series 100 Problems from Around the World. Today we are in Lithuania for Lithuania Math Olympiad of 2022, and this is their team selection test for Baltic Way Olympiad, which is Olympiad held between the countries of the Baltics. So, this is a very interesting problem, a little bit heavy in case working, but typology of problem which very often is seen in math Olympiads. So please bear with me during the calculations of this problem, and we have find all quartets of natural numbers a, b, c, and n such that 2 to the power a plus 2 to the power b plus 2 to the power c plus 3 is equal to n squared. Please let me know in the comments of any possible solutions before we start with analyzing this problem for the solution we have found, so in order for us to compare our solutions at the end. Now, let's reveal our solution step by step so we can see what we have thought about the solution of this problem. But as I said, this is a little bit heavy in calculations, but it is a type of problem who very often appears in mathematical Olympiads, so it is quite fruitful to talk about it. So we are asked to find all quartets of natural numbers a, b, c, n such that they fulfill this equation over here. Now, the first thing we can do is to make some restraints about the numbers in this equation, and without loss of generality we can say, given that the equation is symmetrical to ABC on the left hand side, let's suppose that A is smaller or equal to B, smaller or equal to C. Now, it is clear in this case that n should be greater or equal to 3 because the least possible value the left hand side can take is equal to 9. So also n should be greater or equal to 3 in order to be 9 and upwards. So first of all, let's say that we can pick some possible values of a that such that a is greater or equal to 2. Now, if a is greater or equal to 2, this means that 2a, 2b, and 2c are congruent to 0 modulo 4, which means that all these three numbers are divisible by 4, because of course they will have much more than one 2 in their representation. So in this case it means that the sum 2a plus 2b plus 2c plus 3 will be congruent to 3 modulo 4, because when this expression is divisible by 4, given that all of these are divisible by 4, the remainder will be equal to 3. But we know from very basic mathematical facts and from previous problems we have seen in this channel, so a perfect square cannot have a remainder of 3 when divided by 4. All possible remainders of perfect square when divided by 4 are 0 and 1. So we just proved that a cannot be greater or equal to 2. The only possible value that a can take is a equal to 1. So we just constrained one of the factors of this equation, and we will now get that 2b plus 2c plus 3 plus 2, because a is equal to 1, so plus 5 is equal to n squared. Now we should continue the same reasonings even for the remaining part of this problem. Now, with the same logic, let's suppose that in this case b is greater or equal to 3. This would mean that 2 to the power b and 2 to the power c will be congruent to 0 modulo 8. So when 2 to the power b and 2 to the power c are divided by 8, they will give a remainder of 0 if b is equal or is greater or equal to 3, and consequently even c, which is greater or sorry for the lapsus, greater or equal to b will also be greater or equal to 3. So we'll have that when 2b plus 2c plus 5 is divided by 8, it will give a remainder of 5. But again, we have a contradiction, because in the same way we have proved that perfect squares are congruent 0 or 1 to modulo 4, we can prove that perfect squares are congruent to 0, 1, or 4 modulo 8. And in this case, we have congruence 5 to modulo 8. So this means that this sum cannot be a perfect square if b is greater or equal to 3. In this case, we just prove that beside a is equal to 1, b can take only two values, b is equal to 1 or b is equal to 2. Now let's make good of what we have. Let's suppose that b is equal to 1. This would mean that in this equation over here we will get that 2 to the power c plus 7 is equal to n squared. Now, in the same idea, if c is greater or equal to 3, we will get that 2 to the power c plus 7 is congruent to 7 modulo 8, so it is not a perfect square because it doesn't give these remainders. So in this case, we are left that in order for this sum to be a perfect square, c can only take two possible values when b is equal to 1. C can be equal to 1 or equal to 2. Now, for c equal to 1 and of course b equal to 1, we will get that n squared is equal to 9, so n is equal to 3, and we just got ourselves a solution 1, 1, 1, 3. If c is equal to 2, for b equal to 1, of course, we will get that n squared is equal to 11, which doesn't have any solutions in the set of natural numbers. Now, let's go to the case where b is equal to 2. In this case, we would have that 2 to the power c, so this equation here would become 2 to the power c plus 9 is equal to n squared. Now, let's do some simple calculations over here, and we will get that n minus 3 times n plus 3 is equal to 2 to the power c. We can divide c, let's say we can say that c is equal to x plus y, where n minus 3 is equal to 2 to the power x, and n plus 3 is equal to 2 to the power y, where x plus y is equal to c, and of course y is greater than x because n plus 3 is greater than n minus 3. And given that we already defined that n is greater or equal to 3, they both will be positive numbers. So by subtracting, for the case over here, by subtracting side by side the two equations, we will get that 2 to the power y minus 2 to the power x is equal to 6, or by factorizing 2 to the power x, we'll get 2 to the power x times 2 to the power y minus 6 minus 1 is equal to 6. Now, in order for these two sides to be equal to each other, x can take these values 0, 1 of 2. Because if x is greater than 2, then left-hand side will be bigger than 6. Now, we should take case by case, and we find that for x equal to 0, we get that from this condition over here, 2 to the power y is equal to 7, which doesn't have any solution. For x equal to 1, we get that 2 to the power y is equal to 8, or that y is equal to 3, which gives in this case c is equal to 4, because x is equal to 1 and y equal to 3, and c is the sum of these two numbers, we'll get c is equal to 4. So we just found ourselves another solution. A is always 1. B is equal to 2, because this is the case we are discussing, and we just found that c is equal to 4. By making these substitutions into the initial equation, we get that n squared is equal to 25, so n is equal to 5. So we just got ourselves another solution. Now, we have the last case where x is equal to 2. In this case, we would get that 2 to the power y is equal to 10, which doesn't have any solution in the set of real numbers. In the set of natural numbers. So, what we can finally say is that all possible solutions, a, b, c, n, of the given equation up here are 1, 1, 1, 3, and 1, 2, 4, 5, but beware, because from our initial condition, we just suppose that a is smaller or equal to b and smaller or equal to c, but in this case we could have let's say shifted the places, and we should get into account even other permutations of this solution. So not only 1, 2, 4, 5, but also 1, 4, 2, 5, 4, 1, 2, 1, 4, 2, 2, 4, 1. So all the permutations of these numbers, which actually are 6 possible permutations. So in total, this equation has 7 solutions in the set of natural numbers. So I know a little bit of a lengthy video compared to the other videos of this channel, but it was necessary in order to go through all these heavy calculations. Please let me know what you think of this solution, and maybe let me know any other possible solutions shorter in let's say in the comments down below. Thank you very much for your time, and hope to see you on our next videos. Goodbye.